Hello and welcome back to the channel. It's Mark from PowerSonic and Apprentice 121. I've got an exciting new product to show you today. I'm going to run through the installation of it and talk about all of the features, but it's one we have not used before and they're from Collingwood. So this is the Collingwood H2 Sense, which is a downlight, but uniquely, depending on the type of bezel you use alongside it, you can have PIR detection built in to the spotlight. And there's two ways you can go about achieving it, and I am obviously going to go to the extreme end in this little space we've got here by fitting 6 of these spotlights with individual PIR controls on them. I'll just jump them out the box and show you exactly what you get in the kit, and then we'll run through getting them into the ceiling. So there's 2 component parts, as you will most likely be used to with your downlight installations now. We've got the detachable light fitting itself, which just unplugs there, and then you've got the driver pack, if you like, and your termination pack. And with this one, you'll note, if you can see that, there is 4 terminals in there. So you've got line, neutral and earth, and then a terminal marked L1. We'll get to that later on. On the bezel, sorry, it's not the bezel, on the can itself, you can see you've got your 3 color codes. So it's 2.7, 3 and 4K. You can see that there up on camera. And again, it's handy that they're detached because then you don't have this dangling around in your face while you're wiring this up. I'll show that closer up when we are actually fitting it. There is another part, and that is, the bezel itself. Now you'll see on the front of the bezel there's a little cap, if I hold that sideways on, to house the PIR, and a little glass shield, which I assume is for some LED indication. And on the back there's some dials. Now those dials are where you make your adjustments for your time, lux and sensitivity. And there's 3 little prongs just on the bottom here, which connect into the can itself when you fasten it on. So if you can see on the can here, there's the little dots. You might not be able to see them on camera, but those 2 parts mate together, and that then gives you your PIR detection in the bezel itself, which I think is kind of cool, because that allows for a few different setups. You don't have to use a PIR downlight on every single one of these in this room. We could just have one over the doorway here and then link out from that to the remaining downlights, and that's what that 4th terminal is for. So you'd put your line, neutral and earth into that first light, then the output from that would feed on to the other lights using that L1 terminal. That way the PIR that's at the door triggers all of the rest of the lighting together. Equally, if you've got a couple of spaces where people are entering the room, or they've got some work areas that you want a PIR detector local to. So it could be that there's a desk in this back corner here that someone's going to go and sit at. We could have a secondary PIR in that circuit up there that links back in the same way to activate other lights than itself. But I thought, for interest, within our little example here, and for those of you who watched the prior video of installing these spotlights, you'll know they don't all loop on from each other in the traditional sense. We might do this. They go back to a central wiring point. We're just going to install 6 PIR downlights and then see if they will maybe come on as we wander around the room. I guess that depends on the adjustment of the sensitivity, but we can get to all of that. I'm going to get set up. We'll pop these lights down, carry out safe isolation, and make sure we've got a safe state to get these Collingwood H2 Sense fittings up into the ceiling. So let's get on with that right now. So you can see I've popped the lighting on down here, and we're lucky in this room because we've got the spotlights, the downlights, wired off the distribution board down the other end of the bays. And the rest of this room's on its own little consumer unit you can see behind me here, so we can keep these lights on while we work and still be safe. I'm going to take you down to that distribution board and show you how we would go about locking that circuit off. Now, there's the process for safe isolation. There's the ESR guide, which is the 12 steps, and then you've got the best practice guide as well, which shows you how to go about carrying out safe isolation. But the fundamental principle of it is that at the end, before you go to work, the system you're interacting with is de-energized. How you get there isn't as important as that final fundamental principle. Sometimes we can get wrapped up in the processes of you must do this, you must do that, and lose sight of the important thing we're trying to achieve. And in my case, it's not as straightforward as it might be with this, because none of the distribution boards here are marked. So I'll show you that. There'll be a common thing you maybe come across out on site. Speaking for apprentices and trainees, obviously more experienced electricians will have seen this 1,001 times already. but none of these are marked. We've got no real idea of knowing what is what. You can use a circuit tracer. We've got the Klein Tools one where you can go and pop your transmitter in at the end of line on your final circuit, come back to the board and start buzzing through, and it'll show you what it is. You can make inquiries. I'm lucky that we know that it's this B6 breaker here, and I can visually prove that point by banging the power off to that breaker, and the lighting in that room has gone off for those downlights now. Now that isn't a safe isolation process. We've not verified that those circuits are de-energized, but it's allowed me to identify it. And I'm now able to pop my little lock in position. So at least that circuit is now isolated and has a lock through it, which is the base camp to start from. There is no one else here anyway, it is just me, and I've got the front door locked as well. However, having an element of control and the key in your pocket is a good bit of reassurance that that state can't now change. So if we go back to this room, having made the isolation that we have, and we've done all of the stuff about seeking permission and all of the other important steps that are needed, check your circuit charts, but we can now pop one of these down and see if there's any live voltage there. And you do that with your voltage indicators and your proving unit. So I'm just going to pop one of these down and we'll double check that there is no live energy down in this circuit any longer. Okay, so now we've got that circuit locked off and we're reasonably confident it is the right one because the lights have gone off. But you know, there could have been something else at play and it's not actually this circuit. So you need to assume that it is still a live circuit. And the beauty of these existing spotlights is you don't need to access any live parts to get in and around those terminals. So you can see now we've dropped this connector down and we can see the ends of them. I've got my proving unit here and my TAS 859. I'm going to drop them in just to check that this instrument is working before we start anything. Hope if I actually got it in the right position. And if you can see on there, we're measuring 850 volts. So we know this is working. The tips on these are retractable. You see that pops down, but these are a little bit fat for the terminals. They do screw off the end of here. So these little holes in the end of these connectors aren't the biggest. Obviously they don't want people sticking their fingers in and whatnot. So it's a good product design, but our probes need to be small enough now to get in. So we can pop those in there, no voltage measured between our line and neutral. So that's a good start. We can now check between the CPC and the line, and again, no voltage there. And then finally, between the CPC and the neutral, and again, no voltage there. So we can check the instrument again on the proving unit. See if we've got voltage still measuring, so we know that that is working. And again, 850 volts. It's doing its little vibratory on there. And I can pop my caps on the end of these probes before I lose them. We now know that circuit is dead. There's no power flowing through that. Our isolation is the correct circuit. We've got it locked off at the source. And there's a handy little guide that Proteus have produced, which is separate to the best practice guide and the ESR guide, but it's great that we have these resources available to us, and I've shown this before on the channel, but this is a process you can follow. So before you start, you need to get permission. You then need to find your spot, which we did back at that distribution board there, and that's a double pole type A RCBO from Proteus and bidirectional, so it's littered with features. So we've been able to isolate our line and our neutral, which is both live conductors, something we need to try and be doing. Even if it is a TNCS system and you can assume the neutral and earth are bonded together, having both of those conductors isolated at source is a great stage to be before you go to work. So then check your equipment, so you're checking all your leads, that they actually work. Test it out, so check your voltage tester on a proving unit or known live source. Switch off, so make sure switching off is not going to cause any damage. You don't want to be turning someone's server off or whatever, causing them a problem. Make it secure, so lock it and get the key. Warn any others. As I've said, I'm the only person in here, but You know, if this place was occupied and the lighting's going to be off, you can say the light's going to be off for an hour or two, keep out, this kind of thing. Test the circuits. You need to verify the circuit and equipment are dead by checking between the live conductors and earth at the access point. And then check it again on your proving unit. Step 10 on this little list. Everything is good. And I will reference in alongside this video links to the ESR guide and the best practice guide. And there's going to be times when that process is something we're just doing by habit and it's not in the exact sequential order. If you're doing a void for an EICR, for example, there's no one there to ask. You know where you're making your point of isolation, and a lot of that's just done by default and experience. And you might not get it all in exactly the right order, but as I said at the start of this video, when you come to do your work, you're in that safe state with the voltage not in place, which is what it's all about. So I'm going to run around now, take all these off. We need to take the connectors off as well and get them ready for putting the Collingwoods up. I'll stick you in this back corner, maybe time lapse it, maybe not, and you can see all these get pulled down. So I should just stay around safe isolation. If you are working on multiple points, you should repeat that check at every fitting before again you access those live terminals. This is a known circuit to me. I know how it is designed and laid out, but there will be installations where you are none the wiser as to which accessories are connected into that circuit. So do repeat that process at each point. So you may have seen that just sped up or not. And I've realised I can't change them all because I only ordered 4 and not 6. So I was lying at the start. But again, similar kind of connectors, the old push fits. In there we've got line, neutral and earth. So in this case, the way we're using them, they're all going to go in the line, earth and neutral. And we're not going to use this L1 output, which is basically the PIR. If this was our PIR sensor, it would output its voltage through the L1 to then feed onto the other lights we then wanted to power. But that's not how we're using it in this application. So we can pop these in and they just push in, same as any other push fit terminal you've probably fitted 1,000 times over, but they're going in nice, which is good. I did have some issues with some brands and their push fit terminals not quite bedding in, so it's nice to see that these are going in as we need. I'll show you a twin one and a single one so you can see the difference in the way they push together. This is testing me. I didn't put my glasses on. I should have done. So with these, as long as you get kind of straight in, I think that's where people sometimes struggle with these. If you don't get sort of straight down in your terminal, so in your push fit, it won't bed in and they'll start popping out. That's often the complaint with those. Then you can see we've got our clamp, so we need to get our cables in, make sure we've got no basic insulation outside of that, and squeeze the prongs together. So that's now clicked down tight, and there is a little screw terminal in the back there, so you can put a screw through. So this then needs the use of a tool to open it. I'm not going to do that in this case because we're probably going to be swapping these again in a couple of days as we make adjustments and take people through their training in this space. But if you were doing that on a fixed installation, you'd want to have that, so you needed a tool of some sort to access it. And you'll notice from the ones I've taken down, that wasn't the case with those. Those covers could just be removed without the use of a tool. So that's just to show you the wiring instructions. While I'm on with it, you can see what I mean about the line, earth and neutral coming in. And then there's this switch line terminal here. If you were feeding that out to trigger these other lights, you would do that in that configuration. And again, if you've got a couple of the spotlights that have been used as the PIRs, you can link onto one here that would just kind of feed that one on, and then it feeds on into that one and so forth. But this last one here, you can see it's taking the line through to the end and then been used in itself as a switch line for a second sensor. And then that just connects back in again on the L side. So basically either one of those sensors would trigger the lights. It makes sense when you think about it, but seeing is believing sometimes. So it's nice there's a little circuit chart in there explaining how that does actually work. But yeah, we've got that done now, so we can pop the light fit in on the end. Should be a simple enough job. Again, just clips together. We can pop that up the hole. Hopefully the holes are a similar size, or this best laid plan will fall apart pretty quickly, and the light fitting goes up into the ceiling. See, that's gone up there. And then the last little job is the bezel. Now it says on the front here that make sure the arrow aligns to direction of travel for the optimum PIR sensitivity. So it wants you to point that in the right direction. And again, you've got the adjustments for sensitivity on the bottom of this. I'm going to leave these off for now and we'll set all those at the end. But that is in and ready to go. So this one's an easy one because it's just a twin and earth straight onto the end. There's only one cable coming in, so I think even I can manage this one. Again, if you want, you can disconnect the light fitting from the underside, so that's not going to be dropping anywhere, but I'm just going to leave this one because it's pretty lightweight. Pop our cable through, make sure we're set roughly straight, and then again we're going line, earth and neutral. Make sure you don't make a mistake on the polarity, and they just push in. Give them a good wiggle test to make sure they are in nice and tight. As we now are. So they're all in, and we can fasten back. And again, if you want, you can use that screw terminal just to hold that in, but we're not going to use that in our case here. And that can go up in the ceiling, ready for the bezel to be fitted down the road. That's nice and snug up there. And again, we'll show the colour adjustments of all this at the end. I'll get the other two up and done, and then we'll jump back and look at the bezels and the light adjustment. So if you can see on the back of these with the markings, we've got the time as the first dial, so I'm going to turn that right down. So we want that on the minimum time. I'm going to turn the sensitivity right down as well, because I'm going to try and see if we can set ones off without the other. And we'll turn the lux right up. I think that's right, because then we should have it working even when it's daylight. I always get that the wrong way around, so we may have to change that. But I'll set all of them the same, and then we'll see where we're stood after that. So we're going for time right down, sensitivity right down, lux right up, and we'll see how they play ball after that. Putting them on, I'm not expecting will be a challenge. Bring you in a little bit closer, and you can have a look with me. Should do us. So we've got the little guide pins that are on the light, and also the bezel. Okay, so I'd misunderstood how these work. The pins actually retract, and there's these little tracks in here. They must be making contact with them, because I wondered how it got its alignment, but it looks like it's actually quite straightforward. You just twist it on, and that should now have made contact. And that way you get your adjustment. So I was wondering about that for when it's saying about pointing it in the direction the traffic's travelling. If it was just fixed to those 3 pins, that'd be really fiddly. So yeah, I didn't think of that. Pop it up so it sits in and twist until you feel it engage with the track. Feel it on there now. And we've got that pointing roughly in the direction people are passing. 2 more to go. Just need to make the adjustments on the sensitivity and such, which I'll probably end up having to adjust because I always set these things incorrectly, but we'll give it a go. So now we've done that and we've finished all the accessing of live parts, I can use my key, go take the lock off, turn the circuit back on and see what the state of play is. Okay, so these lights are on a wireless switch, so if I press that, you can see the lights click in, you can hear the relays, and the PIRs do a little flash to indicate that they are now set. Now the time frame on these is 30 seconds to, and what the maximum is now, 15 minutes. So I've set them to the minimum. I'm going to leave the room now and we'll see if they go off. I'll pop you right to the back over here. So I think we've got all of them in shot. Hopefully they all switch off. We'll give it 30 seconds.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay, so we can see they've all gone off. This one's got me as I walked in the door. This one's picked me up over here. And these two over in this direction. And as we said, it depends where you aim the bezel. It tells you to point that arrow so people are going to cross the beam, and I've not set these up in any way like that. I've just literally threw them up in the ceiling to see what happened. But it's interesting to see how these can be used. This is a really unusual setup. You're unlikely to want all of your downlights with PIR detection built in, but if you did want to do that, Collingwood have allowed that in their range of gear. Usually you'd have a detector over that door, one over that door, and it'd switch the lights all together. That makes most sense, doesn't it? But we're going to use these for varying different tasks in this training space here. They're going to be up and down. We'll be wiring them up in certain configurations, and I just wanted to show the extreme of what could be done. I want to go through quickly what this product can do, and just to make clear, this isn't a sponsored or paid video. I've bought these from CEF, fair and square. Collingwood have not been in contact with me whatsoever. I just thought they were cool and wanted to give them a try. But these are 6 watts, 2,700 to 3,000 and 4,000 K for your colour changing. They are 100 lumens per watt, 108 and 113 based on that light mode. Lumen output again, 600, 650 and 675 based on the colour code. They're non-dimmable. That's a big drawback for these ones. I don't know if you can get them in dimmable format. I assume you maybe can, maybe not with a PIR. Make sure you check that if you do need dimmable fittings. The beam angle is 50 degrees. Your cutout size is 68 to 72 millimeters, and they are part B, C, E, P and L compliant. And yeah, pretty much 5-year guarantee. You can see on there. I'll pop a link to Cities where I bought them from, so you can check out the full product specs yourselves if you want. And again, they come with that wiring diagram, which sets out what I've been trying to explain. All of the wiring instructions on the back as well, and how these should be fitted. So they are fire rated as well, as we would need, which is important when you're putting these into modern buildings of today, that we need to ensure we're getting that fire rating. And it's good to see that Collingwood have got that in the product. If you've got any questions on these, please do drop them in below. I think they're really cool. You can get them in white and black bezels as well as a final note, or at least that's all City's range was for white or black. I don't know if they come with the colour options. Super solution. I'm thinking downstairs loos, where it's a little cloakroom and you've got kids who never turn the light off, speaking from experience on that one, or maybe for the bathroom when people are in and out. You're probably not going to want to put these in a large dining room. You're not going to want those on PIR control, I would say, when people have come to sit down for the dinner. We know what PIRs are like in office spaces, where they will just time out and you've got to start waving your arms around to get the lights to come back on. So it's picking the right application for these. But yeah, I think they're a great solution. Thumbs up from me. Well done, Collingwood. And yeah, if you've enjoyed this video, please do get involved in the comments, give it a thumbs up, thumbs down. Don't forget to subscribe to the channel if you haven't already. And if you are out there working on electrical systems, please do keep in mind the principle of safe isolation. It's not that complicated. You don't always have to follow it to the letter. I know the industry of things gets a bit bogged down. Certainly the comments on YouTube and other social media platforms bogged down in the actual process and regimented this, and that order. But for me, the most important thing, as I've tried to show on this video, is to end up working in a safe state with no voltages present. Thank you for watching, and I'll see you on the next one.